Hey guys, today I will be showing and explaining to you about a neuron. So what exactly is a neuron? If you didn't know, a neuron is a specialized cell transmitting nerve impulses from one part of your body to another part of your body. It is the basic information processing structures in the CNS, Central Nervous System. Let's say a nerve impulse started in your arm or hand. The impulse will be sent from that neuron to another neuron until it reaches the main point or destination, the brain. Then the brain will recognize and analyze those nerve impulses. After it's done being analyzed, the nerve impulse gets sent back to the place the nerve impulse started in. In this case, your hand. Finally, the part of the body that the nerve impulse started from, which again in this case, the hand, knows how to react, move, and make an action if needed. So really, the nerve impulse goes to the brain by other neurons and comes back to the place it originated with information. Well, if you're still confused, just hold on tight because I made this model and I will explain and do my best to make it clear. So here's my model. This is a neuron model. A typical neuron model has four distinct parts or regions. They are cell body, dendrites, the axon terminals. This is the cell body. It is the metabolic control center of the neuron. Like almost every cell, it has a nucleus too. Well, do you see these squiggly lines, red squiggly lines? Yeah, those are dendrites. Dendrites receive information or incoming signals from other neurons. So if one neuron wanted to send signals to this neuron, then the neuron signals that was sent from another neuron will come straight to the dendrites because the dendrites receive and collect the signals. If you come along, here's an axon. The outgoing or leaving signals of other neurons flow along its axon. A neuron may have many thousands of dendrites, but it will only have one axon. Both the dendrite and axon are processing structures that extend away from the cell body. Generally speaking, the function of a process is to be conveyed through which signals flow to or away from the cell body. So then comes these green puffballs right here. Not this one, but these five. Those are myelin sheath that wrap around the axon and protects it. And it also makes the signals go way faster. So if a signal wanted to be sent, these myelin sheath would make it go faster. Well, do you see these dots in the middle? Yeah, those dots are Schwann cells. They are known for protecting, supporting nerve regeneration, and healing the myelin. It will aid in digestion of the axon. Well, since the Schwann cells are on the myelin sheath, and the myelin sheath are wrapped around the axon, the nerve impulse or signal jumps rapidly between the myelin-coated sections from one gap near a fibril node to another node. So when it's sent, it will jump rapidly and out of it. It's also called the node of Ranvier. Node of Ranvier, or periodic gap in the insulated sheet, myelin, on the axon of certain neurons that serves to facilitate the rapid conduction of nerve impulses. So it facilitates and makes it easy for the signal to get out of this neuron quickly. After the axon and all of this other stuff comes the axon terminals. Axon terminals are structures that contain neurotransmitters. Neurotransmitters are chemical medium through which signals flow from one neuron to the next at chemical synapses. Communication between neurons is achieved at synapses by the process of neurotransmission. Synapses are a connection between neurons through which information flows from one neuron to another. So say if this neuron wanted to send signals to another neuron, like right here, then the signal will be sent down here, and these will send it to another neuron by synapses. Because synapses are connections between neurons through which information flows within. So these things will flow it through another neuron. So all the information that flows within to or out of the CNS, all of it. So if you think it's over, it's not over yet. There are 4 types of brain lobes: the frontal, parietal, temporal, and occipital lobe. Well, you think, what do these 4 lobes have to do with the neuron? Well, there is something that has to do with it. Do you think those lobes just work by itself? No. There are different neurons that help each section of the brain do its job or specific role. For instance, some of these neurons help the frontal lobe think with the reasoning and analyze and comprehend. It's where all your brainstorm happens. The parietal lobe is sensory information like pain. Like if you get hurt, the neurons signal the brain about the pain and the brain will send it back with information. Same with the temporal lobe. But the temporal lobe is all about listening and auditory. So if someone says that there's a monkey dancing on an elephant, the neurons will send that words or those specific instructions to the brain. The brain will send it back with what's going on and everything. And then the occipital lobe. The occipital lobe is visual. The brain receives signals from neurons of what we see. So if you see a monkey dancing on an elephant, the brain will receive will receive signals from the neurons of what we see, and then it'll send it back and tell us how to react with a monkey dancing on an elephant. Well, neurons don't only help the lobes, they also help the cerebrum and cerebellum and limbic system and spinal cord too. Well, the cerebrum is where memory is held and sensory information is kept. So like if you saw a monkey dancing on an elephant, the neurons will send signals to the cerebrum saying that this thing should stay in there, kept as memory. Also, the cerebellum. The cerebellum receives information from the spinal cord, and it tells us to do this and not to do this. The spinal cord is the main way how the impulses reach the brain. The spinal cord is everywhere where the nerve impulse can start. So basically, it's all around here through your legs and your arms, to all the way to your brain. Then comes the limbic system, which is behavior and neurons. And it sends signals to the brain about the situation, and the brain will say what behavior to do. Like if someone wants to start a fight, the brain will say like to fight back or not to fight, just let it go. Something like that. So basically, this whole session or video is about that this is the cell body, this is dendrites, axon, and axon terminals. And if one neuron wanted to send signals to this neuron, it will send it from axon terminals to the dendrites, and dendrites will send it to the cell body. But if this neuron wanted to send signals to another cell, then it will come through the axon to the axon terminal, and the synapses, which is connections between 2 neurons, and it will send it down to another neuron. So the neuron impacts and affects the brain and other parts of the body too, but especially the brain. So here it is, the neuron model, and everything about you need to know about the neuron. There you go. Hope you like my video.